All right, so once again, where are we? So 2 chapters down out of 5. Chapter 3, you notice it's our longest chapter. It's all derivative shortcuts. So yes, now you may use your derivative shortcuts. You weren't allowed to use in chapter 2, as I said, but now you can. So you get all the shortcuts. By the way, it doesn't mean this chapter is easy. As you can see, there's 11 sections. Okay, so a quick look at the calendar. We're not scheduled for exam 3 until when? It's like Friday, October 23rd. Okay, so that's going to give us what? Where are we? 1, 2, 3, 4 weeks. 4 weeks until the next exam. Okay, so that means we're going to have several quizzes on Fridays coming up. All right, so expect a quiz, what, October the 2nd, October 9th, October 16th, and then the test on Friday the 23rd. Okay, and by the way, we do have a one-day holiday, something called Flex Day on Thursday, October 15th. Okay, there's always these flex days. So you say, what's a flex day? It is a holiday for you guys. It's not a holiday for teachers. We're supposed to get together and have meetings and all that stuff, but it's a holiday for students. So pretend it's a one-day weekend. It's a one-day holiday. Okay. All right, so this is our biggest chapter. I mean, chapter 4 looks like we have, what, 7 sections. There is no 4, 6. And then chapter 5. And chapter 5, it's actually 4.9. 4.9, I'm sticking in with chapter 5 because that's where I believe it actually belongs. You'll see when we get there. All right, so we're going to learn lots of derivative shortcuts now. Okay. All right, 3.1. Here we go. Differentiation rules. Okay, so what is differentiation? It means taking the derivative. Okay, so when you take a derivative, you're applying differentiation. Okay, the verb is differentiate. So we don't really say we derive a function, we differentiate a function. Okay, and I'll put it, we are recording for those of you that don't have the book and never going to get it on page 172. All right, so derivatives of polynomials and exponential functions. Okay, now if we were meeting face to face, I would go through an entire derivation of a lot of these. I would prove these. Since we're under COVID and quarantine, I'm just going to fly through it fairly quickly. Right? Okay, the first is a constant function. If you have a constant function, y equals a constant, it's a horizontal line. Now, derivative means slope. Okay, keep in mind, derivative means slope, slope of the tangent line. So take a look at this line. Anywhere on that line, what's the slope? Slope is 0. Right? So our first derivative rule is the derivative of any constant function is 0. And again, if we were meeting face to face, I'd make you memorize it. If you want to put it on your cheat sheet, you can. I don't think this one's that hard to memorize. If you have a constant function, the derivative is 0. Right? Just a number. So what's the derivative of 5? 0. What's the derivative of negative 21? 0. What's the derivative of pi? 0. What's the derivative of negative square root of 3 over 4? 0. Okay? You have a constant function. Okay, the next easiest is if you have a linear function. Okay, now what they say is correct, but I'm going to give you my version that I would prefer. Okay, so derivative rules. All right, so 3.1. So this echoes pretty much what the text has. Mr. Stewart, who's Mr. Stewart? The author. If f of x equals a constant, then f prime of x equals 0. So f prime means derivative. Okay, so here's a constant function. Constant function is a horizontal line. What's the slope? 0. All right, next, if you have a linear function, y equals mx, f of x equals mx. Now, to prove it formally, you use the definition of the derivative, right? So I've gone through the derivation. It's being recorded. If you want to look at it, you may. Okay, you take the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, but let's just do an intuitive version of it. Okay, if I have the line y equals mx, right? Y equals mx. Slope means derivative. Okay, what's the slope? Slope is m. And if you do the limit definition, the limit h approaches 0, blah, 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 you also get m. All right? So if we have a linear function of the form mx, the derivative is m. It's just a coefficient in front of the x. There has to be an x, though, not x squared, not x cubed, not square root of x, not 1 over x, just x. The derivative, the slope, is the coefficient. Okay. So that means, what's the derivative of 7x? 7. What's the derivative of negative a million x? Negative a million. What's the derivative of 23x? 23. Right? So that's pretty straightforward, hopefully. All right, next big one, page 173, the power rule. Okay, and here's another notation, d dx of x to the n. You will see me and the book use this sometimes. So I give you the notation dy dx. Well, pretend this is y. Okay, if y equals x to the n, it's like I put the y here, and one notation for derivative is dy dx. I showed you that last time, right? So instead of putting y, they put the actual function here, d of x to the n. Okay, so this is called the power rule. If you have x to the nth power, the derivative d dx, sometimes we say the derivative with respect to x of x to the n is n times x to the n minus 1 power. Okay, now we're not formally going to prove it, okay, until maybe a future section, maybe section 5. We'll just assume it's true right now. I will give you a plausibility argument, okay, right now. So we now know the derivative of x. The derivative of x, it's like 1x. The coefficient is 1, so the derivative is 1. But I'm sneaking in a 1 and an x to the 0 here for some reason. Okay. But x is the same as x to the 1, right? And what is x to the 0? 1. So it's still true, right? But I'm trying to follow the pattern here. Okay. In the previous chapter, we took the derivative of x squared. Okay, it came out to be 2x, which I can write as 2x to the 1. X cubed, that was the last question of the test. The derivative of x cubed, if you did it the right way, comes out to be 3x squared. We have taken the derivative of x to the 4th. The derivative comes out to be 4x cubed. So if you look at the pattern, x to the 1, 1x to the 0. X squared, 2x to the 1. X cubed, 3x squared. X to the 4th, 4x cubed. So it looks like that exponent is coming down in front, and you're subtracting 1 from the exponent. Okay? So by pattern, if we have x to the n, the derivative looks like n x to the n minus 1. So this is now called the power rule. Okay, so the power rule, and again, if we were meeting face to face, I'd say memorize it, but you can put it on your cheat sheet, but this is not that hard to memorize. The derivative of x to the n is now x n to the n minus 1. Okay? I haven't proven it. This is just a plausibility argument, which means, okay, it looks like it works up to here, so it looks like this is the pattern. That does not mathematically qualify as a proof. Okay, so even though it looks like that's the pattern, how do I know when I get to x to the 316th power that it really is going to be 316 x to the 315? Right, so this does not qualify as a proof. I'm calling it just a plausibility argument. You don't have to write that down if you don't want to. Okay, and just reviewing some other symbols for derivative. Y prime, f prime of x, dy dx. Okay, this is how you say it, dy dx. Even though it looks like dy over dx, we normally just say dy dx. All right, so this is the power rule. Okay. The book gives you a little bit of a proof. Okay, it's not really a full proof. Okay, and their proof only works for integers. Okay. We're claiming that this rule works for any real number. Okay, the plausibility argument that they're giving you is that n is an integer. It works for any real number. Okay, so let me give you some examples. So here's a new notation for derivative, d dx of x to the 6th. See, this prevents you from having to say, let y equal x to the 6th, find dy dx. Well, they put the y right inside here. Okay, where I'm normally supposed to put the y, right? dy dx. they just put d of x to the 6 dx, or you can say d dx of x to the 6. See, otherwise you would need two steps. You would have to say, let y equal x to the 6, find dy dx. But if you write it like this, you just get it all at once. That's all. Okay? I'm basically trying to say, don't get scared by the notation. It still means gives a derivative. Okay, so x to the 6th, 6 x to the 5th, right? Bring the exponent down and subtract 1. Okay, so in general, x to the n times x to the n minus 1. Okay, what is x to the 100th prime? Another way you can write the derivative, right? I like this because it's fast, right? You just give the function you're trying to take the derivative and put the prime, right? So x to the 100th prime, 100 comes down in front, and then subtract 1. So 100 x to the 99. Okay, pretty easy, Rue. Get the hang of it. How about y equals x to the 2.3? So y prime is 2.3 x to the 1.3. Right? 2.3 comes down, subtract 1. F of x equals square root of x. Okay, I gave this to you on the test. At the time, you weren't supposed to do the shortcut. You were supposed to do radical x plus h minus radical x over h, and then rationalize the numerator, multiply by the conjugate, and stuff like that. Okay, so some of you did the shortcut. You couldn't do it during the test, but you can do it now. Okay, and by the way, even if you're doing it now, I don't want you to go straight from here to here. You need to show me everything here. You know, a good rule of thumb is do whatever the teacher does, right? If the teacher does it this way, you're not going to be wrong doing it the teacher's way. If you do it another way, the teacher might mark you off. I'm not just talking about me. That's a good rule for all your classes. You know, it's generally a good strategy to do things the way the teacher wants it, right? All right, so radical x means x to the 1/2. Now I do the power rule. 1/2 comes down. X to the 1/2 minus 1 is negative 1/2. Okay, x to the negative 1/2 means radical in the denominator, so 1 over 2 radical x, like so. Okay, then one more example. How do you differentiate? And you said, what do you mean by differentiate? Take the derivative. Okay, so in mathematics and calculus, when we say differentiate, it means take a derivative. You know, and I know there's an English word differentiate, right? But for math, when you say I'm differentiating a function, it means to take a derivative. Okay, not the English meaning of differentiate. Okay, 1 over x. First write it as x to the negative 1 power. Now I do the power rule. So dy dx. And by the way, you'll see me use all different notations for derivative so that you can get used to it. So sometimes I'll use y prime. Sometimes I use f prime of x. Sometimes I use dy dx. Sometimes I'll just write d of x to the 6 dx. Right? So you can see them all. So you can get comfortable with all different notations for derivative. Okay? So don't be alarmed when I write y prime, f prime of x, dy dx. It all means derivative, but I want you to get used to all of it. All right, so negative 1 comes down, but if it's negative 1, you normally just write the negative, right? And then x to the negative 2, negative 1 minus 1. And then don't leave your answer like that, right? We're not supposed to have negative exponents in the answer, so negative 1 over x squared. Okay, so that's the power rule, which we have not proved. We may get to a proof of it in section 5 or 6 of this chapter fully. All right, constant multiple rule, or constant multiplier rule. Okay, what page am I on? 175 now. If you have a constant times a function, a differentiable function. Differentiable means you can take a derivative. So what's the derivative of c f of x? You can take the c out. C passes out in front. So c times d dx of f of x. Okay? So if you have a number times a function, the derivative is the number times the derivative of the function. They actually go through a proof of this. The proof is not that big a deal, but you know, I'm not going to show it to you. But we know that the derivative is a limit, right? The derivative is a limit, and we already have a rule that says if you have the limit of a constant times a function, you can take the constant out times the derivative times the limit of the function. Okay, so I've written it. Well, I use k for constant. The book uses c, but same thing. if you wanted to formally prove it, I have it here. You don't have to look at it if you don't want to, but in case anybody wants to, you do the limit definition, right? Limit h approaches 0 of k times f of x plus h minus k times f of x all over h. Factor out the k, and then it ends up being what you want, k times f prime of x. Okay? So in short, if you have a constant times a function, the derivative is the constant times the derivative of the function. You can write it like this. Now again, do you want to write it on your cheat sheet? You may. I don't think it's that difficult to memorize. Okay? You have a number in front of a function. Just take the number times the derivative of the function. Okay? So here are some easy examples. Okay, so now we can differentiate 7x cubed. Okay? I know how to take the derivative of x cubed now, 3x squared. How do I differentiate 7x cubed? This rule says it's 7 times the derivative of x cubed, which I know is 3x squared. And then 7 times 3 is 21x squared. Okay? So now we know how to handle polynomials of this type. Okay? If I have 7x cubed, all you have to do simply is go 3 times 7 is 21, and then subtract 1 from the exponent, right? Okay? And you may use that shortcut. So 7x cubed, derivative, 3 times 7 is 21, subtract 1, 21x squared. So in other words, you don't have to run through all of this rigmarole here. You can just go straight to it. Here's another one. Quickie. F of x equals 4x to the 5th. F prime of x. So you just go 4 times 5 is 20. And then x to the 5 minus 1 is 4. So 20x to the 4th. And there we go. Okay, get the hang of it? And here's the d notation again. D dx of a half x squared. And don't get scared. It means give me the derivative of this. I could have said y equals 1/2 x squared. Find dy dx. Well, I just wrote y right here. So this saves some writing. Just go right to it. Okay. Now, how do I just get x? Okay. So by this new constant multiplying rule and also the power rule, right? So I go 2 times a half. What's 2 times a half? 1. Well, if the coefficient is 1, you don't have to write it. And then subtract 1 from 2, it's x to the 1. So I have 1 x to the 1, which you normally just write as x. So there you go. Okay. And then let's see, I didn't write it down, but do you remember the derivative of the sine function? Derivative of sine x is cosine x. So how about what's the derivative of 10 sine x? 10 cosine x, right? Just leave the 10 alone, then multiply by the derivative of the sine, which is the cosine. Okay. All right, next rule is the sum rule. It's pretty straightforward. d dx of f of x plus g of x is d dx of f of x plus d dx g of x. Okay. If you want the derivative of a sum, just take the sum of the derivatives. Okay. The formula go through the proof here. You can look at it or not. Okay. It's very obvious. Okay. I'm guessing that would be your guess. That was my first guess. If you have something plus something, how do you differentiate? Just take the derivative of the first plus the derivative of the second. Does it work for a difference? Yes, it does. In fact, a difference is a sum. You can just say I'm adding the opposite. Okay. Difference rule. What's the derivative of f minus g? Well, it's the derivative of f minus the derivative of g. Okay. The derivative of a difference is a difference of the derivatives. If you want to know where I'm in text, it looks like I'm on page 176. Okay, so that tells us now how to handle, something plus something, minus something, minus something, plus something. How do you take the derivative of the whole thing? Just go one at a time. It's the derivative of the first, minus the derivative of the second, minus the derivative of the third, plus the derivative of the fourth, and so on. And just go as far as you want. Okay, so now you can handle any sum or difference. Okay. So I summarize it like this. If you have f of x plus or minus g of x prime, this makes it more compact. Right? It means if you have a plus, you do a plus. If it's a minus, you have a minus. Okay, so what's the derivative of f of x plus or minus g of x? It's f prime of x plus minus g prime of x. Right? If you have a sum, make it a sum. If you have a difference, make it a difference. Right? Pretty straightforward. Example. How do you differentiate x squared plus 5x? Just give me the derivative of this and derivative of this. So what's the derivative of x squared? 2x. Plus the derivative of 5x is a linear function, so I just put the coefficient 5. Okay, how about y equals x squared minus 5x plus 6? Okay, so it's a derivative of something minus something plus something. So it's a derivative of this minus a derivative of this plus a derivative of this. Okay, so this is y. What's y prime? Derivative of x squared, 2x. Derivative of negative 5x, minus 5. What's the derivative of 6? It's a constant. So the derivative of a constant is 0. So it's plus 0. But if it's plus 0, you don't have to write anything. Right? All right. If we were meeting face to face, I'd go over the derivation of the sum rule, but we're not, so don't worry about that. Okay. And the last one is e to the x. How do I differentiate e to the x right now? Okay, so the text goes over that. Exponential functions. It's on page 177. I will go over the actual derivation very quickly. Again, if we were meeting face to face, I would go through it slowly. Okay, but I'll just run through it. You're not responsible for this. But e to the x prime, I would use the definition, right? Limit as h approaches 0 of e to the x plus h minus e to the x all over h. Okay, I can rewrite this as e to the x, e to the h. This is the same as this. You're probably more comfortable going from here to here, but that doesn't mean you can't go backwards also, here to here. And now I factor out the common factor of e to the x. And by the way, in case you're wondering, I don't suggest you take notes on this because you don't have to know this, but I'm supposed to know this. Okay, so if I factor out e to the x, I then have e to the h minus 1 over h. Okay. E to the x is a constant as far as h is concerned. I know it doesn't look like a constant, but if you're talking about h, e to the x, there is no h. So factor out e to the x, limit h approaches 0, e to the h minus 1 over h. Now, I made a table here, but you actually did that. In fact, I think this was one of the quizzes I gave you. Okay? You did a quiz question. Maybe I had an x. Maybe it was e to the x minus 1 over x, but it's the same thing. Okay? It's two-sided limit. So I went negative 0.1, negative 0.01, negative 0.001, and positive 0.1, 0.01, 0.001. If you come this way, looks like I get 0.9995, and this one 1.0005. The limit is 1. So by doing a numerical job, this limit is 1. So the derivative is e to the x times this thing, which we established is now 1. In other words, it's e to the x times 1, or e to the x. Okay. In summary, the derivative of e to the x is itself. E to the x prime is e to the x. Again, if we were meeting on campus, I'd make you memorize this. If you want to put it in your cheat sheet, you can, but that shouldn't be that hard to memorize. It's the easiest derivative of all. What's the derivative of e to the x? Itself. Okay, so the derivative of e to the x is itself. And I'll just hasten to add, if you want the derivative of any other base, like 2 to the x, or 10 to the x, or pi to the x, they're not going to be so good. Okay, the best one is e to the x because its derivative is itself. And let me just add this also. Because the derivative of e to the x is e to the x, watch out, some students do this. Do not do the following. Whoops. The derivative of e to the x is not x e to the x minus 1. See what I did there? Okay. You're trying to use the power rule, right? Say, oh, x comes down, subtract 1. X e to the x minus 1. No, not for e to the x. The derivative of e to the x is simply itself, e to the x. All right. Okay, and what do I have here? I made up my own example, okay, incorporating a lot of stuff. 6x cubed minus 12x squared plus 5x minus 4e to the x plus 7. So how do I differentiate the whole thing? It's just the derivative of this minus the derivative of this plus the derivative of this, minus the derivative of this, plus the derivative of this. Just go one by one. Okay, so what's the derivative of 6x cubed? 6 times 3 is 18. X, subtract 1, so 18x squared. What's the derivative of negative 12x squared? 2 times negative 12, negative 24. X to the 1, and you know if it's x to the 1, just put x. Plus, what's the derivative of 5x? It's linear, so just 5. What's the derivative of negative 4 e to the x? So it's a constant times a function. So the derivative is negative 4 times the derivative of e to the x. But now we know the derivative of e to the x is itself, which means the derivative of negative 4 e to the x is also itself. Plus the derivative of 7 is 0, but if it's plus 0, you don't write it, you just leave it. So there's a derivative. And there we go. Okay, so ready to do some stuff from the book now. Okay, what time is it? 15:02? Won't go too much longer. All right, so 3.1. Yeah, let me try to project some of the book. See, we didn't have to do number 1. What are we supposed to do? 3 to 35, 45 to 51. 3 to 35, 45 to 61. Sorry. Okay, so there's some of that. More. More. And the top over here, I should show you the top there. More. More. And then on the next page, some words. Looks like I've got some word problems here. Okay, so that's up to about 52. Okay. Next page. We were supposed to only go up to 61, so yeah, we don't need that. Okay, we're good. All right. Now, the first few problems are fairly fundamental, so I wasn't going to write anything. I think we just talk about it. It's so elementary, I think. Okay, question 3. What's the derivative? It says differentiate the function. Give me the derivative. 2 to the 40th power. I already give you a trick question. 2 to the 40th. Trying to trick you into going 40 times 2 to the 39th power, right? But it's not. What is 2 to the 40th? It's some constant. What is its value? I don't know. You can punch it in your calculator. It's a number. Therefore, its derivative is 0. Okay, so watch out. It's a trap already. Don't go 40 times 2 to the 39th. The derivative of a constant, 2 to the 40th is a number. What is the number? I don't know. It's some number. You can put it in a calculator. It's a constant. Therefore, the derivative is 0. Okay, so watch out for that. 7, if you can't read it, it's 2t cubed minus 3t squared minus 4t. 2t cubed minus 3t squared minus 4t. So just give me the derivative of this, this, and this. Okay, so 2t cubed. And by the way, you should write down f prime of t. Write one of the derivative symbols like f prime or dy dx, or in this case it would be dy dt. Okay, so 6t squared, right? Negative 3t squared minus 6t. And the derivative of negative 4t is a minus 4. Okay. Okay, for number 9, I'll just say multiply it out first. Okay. There's a way to do it later if you have a product. That's the next chapter. But this one, just multiply it. It'll be what? X squared minus 2x cubed, right? Okay, 11. I actually will show you my notes on this. I did it in my notes for that one. A little bit trickier. Two t to the negative 3/4. All right, so I do the power rule. Negative 3/4 times 2, I can cancel the 2 with the 4, so negative 3/2 t to the negative 3/4 minus 1. That's negative 3/4 minus 4/4. So negative 3/2 t to the negative 7/4. Okay, now another rule about how to give the answer. The original problem started like this. There was a negative exponent. If the problem starts off with a negative exponent, you may leave the answer with a negative exponent. Okay? It'd be kind of hypocritical to say, oh, you got to have only positive exponents, but it started off with a negative exponent. Okay? So we're going to follow that rule. I will follow that rule. So I'll check to see if you guys follow that too. So if we start off with a negative exponent, you may leave the answer with a negative exponent. But if it doesn't, then follow the usual rule of not having a negative exponent in the answer. So in other words, suppose it started as what? 2 over t to the 3/4. Then you should leave it as negative 3 over 2 t to the 7/4 in the denominator. Okay. And by the way, if you went ahead and changed that to t to the 7/4 in the denominator, I wouldn't mark you wrong. You're never wrong for doing that. Okay. All right, 13. F of r equals 5 over r cubed. Okay. The first thing you want to do is, in order for you to use the power rule, you got to bring the r up. Okay. Don't differentiate like this. In other words, don't go 5 over 3r squared. You're inventing a rule which doesn't exist. In other words, you're trying to differentiate 1 over a function as 1 over f prime. It doesn't work that way. Okay. So bring this upstairs as 5r to the negative 3rd. Then you can use the power rule. All right, then negative 3 times 5 is negative 15. R to the negative 3 minus 1 is negative 4. And in this instance, since I did not start off with a negative exponent, you should give the answer as negative 15 over r to the 4th. See that? Okay, so that's what you're supposed to do for problems like this. All right, let's see. 23 is a little bit tricky. X squared plus 4x plus 3 over square root of x. This is a quotient. Okay. The next section will have a quotient rule, but we don't know the quotient rule yet. So what's the only thing I can do is to divide. So just divide this by radical x, divide that by radical x, divide that by radical x. Okay. So here we go. Now, keep in mind, what is square root of x? It's x to the 1/2. Okay, so pretend this is x to the 1/2. So x squared divided by x to the 1/2, I subtract 2 minus 1/2 is 1.5 or 3/2. So x to the 3/2 plus 4, x to the 1 divided by x to the 1/2. So I subtract 1 minus 1/2 is 1/2. And then 3 divided by x to the 1/2. Well, it's just like you bring the x up. And so I have 3x to the negative 1/2. Okay, so I'm going to write it like this. All right, now I'll do the derivative. I'll write dy dx. Okay. So can I write y prime? Yes. Can I write f prime of x? Yes. They're all the same. Unless I tell you specifically, write it this way. Later on in this chapter, you will have to write dy dx for a reason. I mean, there must be a reason why we have this dy dx. Otherwise, why have this funny notation? I would always rather just do y prime or f prime of x. There's going to be a good reason why we have dy dx. And by the way, it does declare what the variables are. Okay, when I see dy dx, the variables are y and x. Okay, but maybe you have s as a function of t, then you're going to say ds dt, for instance. Okay, then you know the variables are s and t. Okay, anyway, so power rule, sum rule. So what's the derivative of x to the 3/2? 3/2 comes down, x to the 1/2. 3/2 minus 1 is 1/2. This one plus 1/2 times 4, 2. X to the 1/2 minus 1 is negative 1/2. Plus This one, negative a half times 3 is negative 3 halves. X to the negative 1 half subtract 1 is negative 3 halves. And again, don't leave negative exponents in the answer because the original didn't. Okay. Well, x to the 1 half means square root, right? So 3 over 2 radical x. X to the negative a half means put the square root in the bottom. So 2 over radical x. And this one, I've decided just go ahead and write as x to the 3 halves. Now, if you want to write that as a radical, you may. But I'm just going to write negative 3 over 2 x to the 3 halves, final answer. Okay. So x to the 1 half means square root. So 3 over 2 radical x plus 2 over radical x because of the negative minus 3 over 2 negative exponent means make it a positive exponent in the denominator, x to the 3 halves power. Okay. All right, so that's how that goes. Okay, I wasn't going to do these. What time is it? Almost done. Okay, but I'll just talk about what you do. Okay, 25 is kind of a trap. Again, that's easy. What's the derivative of e to the 2.4? That's a sneaky one. A hint, it's very similar to how we did number 3. Okay, so that's as much as I'll say about that. 27, multiply it out. So maybe if you just want to jot down in your notes, for 27, multiply it out. 29, do the division. 29. So 29 is very similar to 23. Just take that divided by that, and that divided by that. 31, I will say the only true variable is y. Treat a and b as constants. Okay, so a is a constant, b is a constant, y is the variable here. This says z, if you can't read it, let's try to get a better angle. Oh, that's a little bit better. Z equals a over y to the 10th plus b e to the y. Okay, so the variables are z and y. So if you were to write this using the d notation, you would say dz dy. Okay. All right, I think I'll do 33 and stop there. Find the equation of the tangent line to the curve at the given point. Okay, now we know that means find the derivative. You can use a shortcut. I gave you that question on the test, right? You weren't allowed to use a shortcut then. You are allowed to use a shortcut now. So find a shortcut, plug in, and then use the point slope form 1, 3. Okay, so let me map that up real quickly, and that'll be it for today. So y equals 2x cubed minus x squared plus 1. You're at the point 1, 3. So first find the derivative, y prime. So what's the derivative of 2x cubed? 6x squared. What's the derivative of negative x squared? Negative 2x. What's the derivative of 2? 0. And now I plug in x equals 1. So how come you don't plug in y equals 3? Well, that's the reason why. It's y, not x. My derivative only involves x. Okay, so I plug in 1. 6 times 1 squared minus 2 times 1. That's 6 minus 2, which is 4. That's my slope. Okay, throw it into the point slope form. Point slope. So y minus y1, y minus 3 equals m4 parentheses x minus 1. And again, you can stop there. In general, you may stop right there once you have the point slope form. All right, so that's it for today. Let me stop the share and check the chat. Quickly. Okay, can we use shortcuts from here on out? Yes, unless I tell you do it by the limit definition, which probably isn't going to happen that much anymore, except maybe very occasionally in the final exam. But yes, go ahead with that, and Prasanna got that. Similar to limit laws, yeah, basically, you don't have to do a limit h approaches 0, f of x plus h minus f of x all over h. You're doing it hardly ever from here on out. Maybe just a few times, and maybe for the final exam. Okay? All right, anybody else quickly? Otherwise, that'll be it for today, folks. Okay, so that's it. So everybody have a good day. Stay cool. It's a warm day today, I guess. Okay? All right, so have a good day. We'll see everybody tomorrow. Okay, thanks. Bye, everyone.